magnesium hydroxide, some compound that contains hydroxide. Yes? Okay? I could increase the hydroxide concentration. So, Becca, if this were the hydroxide concentration of that solution, I'm sorry, Gina, if this were the hydroxide concentration of that solution, then this would be the hydronium ion concentration, and the pH would be the log of this, change the sign. So my solution that I had added sodium hydroxide to would have a pH of 12.4. A basic pH, huh? Okay, let's introduce some new terms, shall we? And then we'll take a break. These are words that you are familiar with, but your sort of seat-of-the-pants idea about these terms is really different from their strict definitions. You heard the word acidic, basic, and neutral before, yes? You know that something that's acidic has a pH of less than 7, something that's basic has a pH of more than 7, something that's neutral has a pH of 7, yes? Here's the thing. The definition of the word acidic is where hydronium ions outnumber hydroxide ions. In other words, the concentration of hydronium ion is higher than the concentration of hydroxide ion. Definition of acidic. Hydronium ion concentration greater than hydroxide concentration. Guess what the definition for basic is? Hydroxide concentration greater than hydronium. People in math and science like symbols because we can write things faster. That's what I just said, isn't it? An acidic solution meets this criteria. Hydronium concentration greater than hydroxide. We make a basic solution by turning the arrow around. And guess what a neutral solution is? When they're equal. Now, I'll remind you, back to our example of pure water, when each of these was 1 times 10 to the negative 7 moles per liter, they were equal, huh? And if one goes up, the other goes down. So if hydronium goes up, hydroxide goes down, we have an acidic solution. If hydroxide goes up and hydronium goes down, we have a basic solution. When they're equal, they're neutral. Just a quick one. You don't have to have pure water, as we'll find out, to have a neutral solution. If I add a compound to the water that does not change the balance of hydronium and hydroxide, like sugar, sugar is neither an acid nor a base, it does not affect the hydronium or hydroxide concentration. So I could have a solution of sugar that would be neutral, right? How we doing? Now, for instance, how do I make a solution acidic? In order to make a solution acidic, I need to increase the hydronium concentration, and I would do that by adding an acid. And we have to be careful, because if you look back to your table, is ammonia NH3, is it an acid? But if I add that to water, the solution does not become acidic. Is it ammonia NH3 also a base? And how strong is ammonia NH3 as a base? Fairly strong. So if I add ammonia to water, NH3, the solution becomes more basic, even though NH3 can act as an acid. So we have to be careful, huh? Is this a base? Yeah, it's a base. It's right on the right-hand side of the arrow, right? However, it's also an acid. And as an acid, it's pretty strong, isn't it? So if I add HSO4 minus to water, HSO4 minus is a base. The water becomes more acidic. So we have to be careful when we say, how do we make a solution acidic? By adding an acid. let's say adding a strong acid. Okay? Now, which are our strong acids? Perchloric, hydrobromic, hydroiodic, hydrochloric, sulfuric. Those are our strong acids, the ones up at the top. If I add those to water, the solution becomes acidic, right? Okay, so, again, the question was, how do I make water acidic? Clear, unambiguous way to answer that question is, add a strong acid, right? And if I ask the question, how do you make a solution basic, or how do I make pure water basic? You'd say, add a strong base. Unambiguous. However, here's the thing. An acid is not acidic. Solution is acidic. Folks, if I said HCl, that's an acid, isn't it? HCl, does it have a higher hydronium than hydroxide, or hydroxide than hydronium? Or are the hydronium and hydroxide concentrations equal? You'd be going, it's HCl. It doesn't have any of those things. An acid is not described as being acidic or basic or neutral. A solution is described as being acidic or basic or neutral. Yeah?
Can solutions dissolved in something other than water dissolved in something like else, would that be?
There is an area of chemistry called non-aqueous acid-base reactions. It's different. Yeah, it's an advanced topic if you were getting a bachelor's degree in chemistry. Yeah, and it's only just touched on. Aqueous chemistry occupies a huge area of acid-base chemistry. Almost all of it is acid-base. When you talk about pH in living organisms, it's all about water solutions. When you talk about soil pHs in agriculture, it's all about water solutions.
That's kind of an interesting question here. That's not very smart. But how is HCl? How does it not contain hydronium and hydrogen?
HCl. I don't see H3O in that. Or OH minus.
Okay.
Now, if I add HCl to water, ooh, that's a different thing, huh? Because if I add HCl to water, I'm going to change the balance of hydroniums and hydroxides, aren't I? And affect whether the solution is acidic or basic or neutral, right? Okay? You get it?
Wait, then how would...
So, the terms acidic, basic, and neutral are adjectives we use to describe what? Aqueous solutions. Okay? And it's time.